Hello, welcome. In this short video, let us look at an example illustrating how to extract the Z transform and the corresponding signal from a given pole 0 plot. So given the following pole 0 plot, now we are given two zeros and two poles. So one 0 at the origin, one 0 here, and another 0 at a point Z2, which is equal to Z1 is at origin, Z2 is R cos omega naught. R is the radius of the circle. So we have two zeros, one at 0 and one at R cos omega naught. So both are on the real line. Now we also have two conjugate poles, that is two poles that are conjugate of each other. So one is given at R into e power j omega naught, that is at this point. And the other one is given at its conjugate location, that is R into e power minus j omega naught. That is we have P1 equal to R into e power j omega naught and P2 given at R into e power minus j omega naught. Now this is the given information. Now we have to find the corresponding Z transform and also the signal. Now recall the definition of the Z transform x of z in factorized form, that is we are representing a rational Z transform in factorized form. It can be represented as it can be written as x of z, the term g, x of z is equal to g times the product k is equal to 1 to 2, since we have only two zeros, so product is k equal to 1 to 2 z minus zk, and in the denominator we have product k is equal to 1 to 2. Again we have poles, that is two poles, so we have k equal to 1 to 2 z minus pk. Now by using the values of zk's and pk's, that is z1 is equal to 0, z2 equal to r cos omega naught, p1 is equal to r into e power j omega naught, and p2 equal to r into e power minus j omega naught, and then substitute all these values in the definition of x of z, that is in this factorized form. We get g into, the first one is z minus 0, so z, and second one is z minus r cos omega naught. Those are the factors due to the zeros, and then due to the poles we have z minus r into e power j omega naught multiplied by z minus r into e power minus j omega naught. So this is the Z transform in the factorized form. Now this can be written, now this Z transform can be rewritten as g into z square minus r z cos omega naught, and in the denominator we have z square plus r square minus 2rz cos omega naught. Now this is the Z transform in polynomial form, but the powers of z are all in positive. So we write this one in terms of z power minus 1, that is we write this one as a rational Z transform with polynomials which are functions of z power minus 1 or z inverse. So x of z is equal to g times, by dividing both the numerator and denominator with z square, we have 1 minus r z inverse cos omega naught over 1 minus 2r z inverse cos omega naught plus r square z power minus 2. So this is the rational Z transform with polynomials as function of Z inverse or polynomials of Z inverse. And now from the given pole 0 plot we can also see that the ROC is the region outside the circle of radius r, that is this radius is r. So the ROC is outside the circle of radius r, so ROC is mod z greater than r. So this is the ROC. So we have derived the Z transform. Now the next step is to extract the discrete sequence, that is we have to find x of n, which is the inverse Z transform of this x of z. So by applying partial fractions to the given Z transform, now the next step is to write the following expression using partial fractions, that is we have the Z transform in factorized form, that is z into z minus r cos omega naught over z minus e power j omega naught multiplied by z minus r into e power minus j omega naught. Now we want to write this expression as sum of two fractions, that is two partial fractions. So it can be written as az over z minus r e power j omega naught plus bz over z minus r into e power minus j omega naught. So that is the expression of this ratio as partial fractions. Now we have to find the coefficients a and b. Now by simply comparing the coefficients of the z power 1, that is we have minus r cos omega naught on the left side, which should be equal to minus a r e power minus j omega naught and minus b r e power plus j omega naught. So by comparing the real components on both sides, we can simply write this expression as the real parts. It is comparing the real parts. We have minus r cos omega naught is equal to minus of a plus b r cos omega naught. So we have minus r cos omega naught is equal to minus of a plus b r cos omega naught. And for the imaginary components, we have 0 is equal to minus of a and then minus of sine omega naught into r, and then we have minus b r sine omega naught. So the first equation gives us a plus b is equal to 1, and second equation tells us that a is equal to b. Therefore a is equal to b is equal to 1 by 2. Therefore the partial fraction expansion of the given z transform is x of z is equal to g by 2, and then we have z over z minus r into e power j omega naught plus z over z minus r into e power minus j omega naught. Clearly this can be rewritten as g by 2 multiplied by, divide both the numerator and denominator with z. That means we have 1 by 1 minus r into e power j omega naught z inverse plus 1 by 1 minus r into e power minus j omega naught z inverse. So therefore x of n can be written as g by 2. Now this z transform can be seen as basically a z transform of the sequence alpha power n u of n, where alpha is r into e power j omega naught. So the corresponding signal is r into e power j omega naught power n u of n. And for the second component, it can be easily seen as r into e power minus j omega naught whole power n u of n. So clearly this z transform, this expression or this z transform is the z transform of the sequence r into e power j omega naught power n u of n, and this one is r into e power minus j omega naught power n u of n. So upon simplification, the sequence or the signal x of n can be easily shown to be g by 2 multiplied by r power n u of n, and then you have e power j omega naught n plus e power minus j omega naught. So this one is clearly equal to 2 cos omega naught n. Therefore the final expression for the signal x of n is g times r power n cos of omega naught n u of n. So that is the required signal. To summarize, we have looked at an example which illustrates the extraction of z transform and the corresponding signal from a given pole 0 plot. So in this example, we are given a pole 0 plot which has 2 zeros and 2 poles, one 0 at origin, other one at z2 equal to r cos omega naught, and poles, that is p1 at r into e power j omega naught and p2 is equal to r into e power minus j omega naught, that is its conjugate. Now the first step is to write the z transform from these poles and zeros in the factorized form. So once we have an expression of the z transform, we can express that one in terms of z inverse. That is a regular, that is the conventional expression or conventional mode of expression for z transform. And then to find the actual signal, that is the original discrete sequence, we have to invert the z transform. That is, we have to find the inverse z transform. So the inverse z transform can be easily determined by using the partial fraction approach, where we divide this z transform as a sum of these two fractions. And then we have x of z, that is the z transform, written as the sum of these two individual z transforms, where we have 1 by 1 minus r into e power j omega naught z inverse plus 1 by 1 minus r into e power minus j omega naught z inverse. So these expressions are basically z transforms of r power n e power j omega naught n u of n. That is, it's like as a transform of alpha power n u of n, where alpha is r into e power j omega naught. And then on further simplification, we find that the actual sequence x of n is basically g times r power n cos of omega naught u of n. Thanks for watching.